This is the last of the videos that have to do with the overall design and structure of classes and their methods and the big ideas of how things work. And we have two other terms to define. We define the scope of a variable and the lifetime of a variable. But let's go back just a minute. A class definition consists of two parts. You have your list of private data members of instance variables. Those are what define the class. And you have a list of the methods, the behaviors. What can that particular object do? And let's also focus on the next. When an object is instantiated, it receives its own complete copy. We've drawn on the board in the class how we imagine it all encased in a box, and it knows the values of its own private data members. It knows what behaviors it can use, the methods that have been defined, and it can activate a corresponding method within its own class. We haven't actually looked at that, but it can actually grab a method inside itself. We want an object to contain its own data and respond to messages. We call that with our driver. The role of classes is to provide the template that is that definition. The scope of a variable is where can this variable be used? Inside the whole class, inside the driver, inside a method of the class. The lifetime is how long does the variable exist in memory. So they are two different kinds of ideas. When a method's executing, one of the objects had to call it. A particular student object calls the setName method. The method is inside the object, and so it has access to all of its own private data members, all of its own instance variables. We would call these variables, the instance variables, the private data members, global variables, because anything within that class can use those variables. They are global to the entire class. Variables inside one method are local. Only the method itself is able to use those. So let's define scope more completely. The scope of a variable is that region of the program within which it can validly appear in lines of code. The scope of a parameter or a local variable is restricted to the body of that method. And here's saying something different than we said in our previous video. The parameter that is used as part of the declaration of the method is also a local variable, in addition to any ones that we declare inside the method. The scope of a global variable, all the methods can use it. And you will get a syntax error if you try to use a variable, but you don't have access to it. And here's just some silly but descriptive identifiers. Let's say that we have a class scope demo, and you have a private data member, which is an integer, and it says I am global. That means that this variable, I am global, can be seen anywhere inside the class. And that is because it is declared right here. It is declared within this opening and this closing curly brace. So that's where it is visible. So we would say that the scope of I am global is the entire class of scope demo. Now, inside this method, named client method, you have a parameter called parm, and you have a local variable named I am local. Now it is easier to understand that I am local is available only inside this method. Think of the open, close, curly braces where the variable is declared as walls with no windows. If I were to go right here and try to use I am local, it would give me a syntax error because I am local lives within the house defined by this curly brace and this curly brace and cannot be used anywhere else. But parm is also a variable that is local to the method client method. So in this particular case, we have two variables that are local, parm and I am local. The only place they can be used is within client method. So you see the three dots, so there is more to the implementation of this method, and I am local and parm can be used. And this is just another example here. If I were to ask you how many local variables does helper method have, you would notice the open and close curly brace. The easy one to remember is local is this one, I am local too, but parm1 and parm2 are also local to the method. Remember that the lifetime was how long does a variable live? How much time does it exist in memory? And how long can it be used? Local variables and formal parameters exist only during each execution of the method. The driver calls the method, the local variables are created, used, and then they're given back to memory. Instance variables, private data members, however, last as long as the object is in memory. You instantiate an object, you use the word new, and you grab memory, and every time you do that, you set aside memory within that encapsulated object of brand new instance variables. But when the object is no longer being used, the memory for the instance variables go back to the computer as well. Now, it can be confusing what you name your variables. Do they always have to be the same? If I had multiple variables named with the same identifier, would I get a syntax error? Well, you have to be careful with that and understand the idea of scope. Because as long as the scope doesn't overlap, you can, and sometimes it's a good idea to, use the same identifier in a slightly different way. For instance, in this slight modification of a class demonstrating scope, we have our global variable up here, I am global, but then we have a client method and a helper method, and both of them have a parameter named parm1. This is actually no problem at all that they're both called parm1 because the only place parm1 up here in this method exists is between these open and closed curly braces, and the only place that this parm1 down here exists is within these open and closed curly braces. You might name it like this because you might want it to do a similar task in the client method and the helper method. In addition, I am local up here in this one is named identical to I am local down here in this one. But once again, that's okay too, because the only place that I am local is visible in this method is between its open and closed curly braces. Similarly, this I am local has no idea that this one even exists. And let's draw some diagrams now. We're going to go back to the code that we used when we talked about methods. But remember that this was an illustration that I gave a 1, and that was passed down and used inside the method. It was called I, and test score was the second parameter. Here's what happens. Inside the computer, we have S, and it refers to a student. And we know that it has contents in here, the private data members. We also have an integer named test score. And it has the contents of 97. Now when we call set score with this student S and ask it to pass 1 and test score to it, here's what happens. We're now in the student class. We have a local variable I. I grabs its own memory space, and it is filled with whatever was passed here, and that is filled with a 1. Local memory is created for score. It's an integer. So here is score. And the value of score, which is 97, is given to score. And then it is used, I is used with inside the method. We're done with the method. We reach this curly brace, and this memory goes away, and this memory goes away, and we are done. After we go back, the private data members have been changed inside here. They're now changed. Well, just the single private data member for test 1. But this has been released back to the computer. And while you're looking at this slide that first talked about scope in this movie, I'd like you to try to identify this music. No cheating using music identifying software.